G'day, it's Mr. Kane here again, and we're going to look at our happy atom again and what happens when it's not as happy as it could be. So what makes a happy atom? Well, here's one. The atom's happy when its positive and negative charge is balanced. So it's got the same number of protons as it has electrons. So here in the nucleus we've got 3 positive charges and we've got 1, 2, 3 negatives outside, so that's 3 plus equals 3 minus. So the charge is balanced, it's happy, and its outside valence shell is full. If we look at our atom over here again, we've got 1 in the outside shell, we've got 2 in the inside shell. That works, so that shell's full, but the next layer out can actually hold up to 8. So this is not a happy atom because its outside shell is not full. So what can we do about it? So this one here, neon, it has got 8 in its outside shell, so it is a happy atom. Now most atoms don't get both of those at the same time. The noble gases do, that's why they're so unreactive. They're happy, they don't want to do anything. So the ones that don't have that, they go for the full outer shell. So they'll do something to get themselves a full outside shell. That might mean they lose an electron, or it might mean they try and get hold of one. So sodium, for example, has 1 in its outside shell. It's going to lose that to give itself a full outside shell. Then it won't be electrically neutral because it'll have 1 more proton than electron, so it'll have a positive charge, but it will have a full outside valence shell. It'll be happy. So that creates an ion. So an atom or a molecule that's got a positive or a negative charge. Let's look a bit more at ions. So we've got what's called a cation, and that's an ion with a positive charge. Okay, a plus. It might have the T in cation. Yeah, remind you that the cations are positive. Okay, so it could be a single charge, or it could be a 2 plus or a 3 plus. We'll look at more of that soon. Okay, the word cat often creates positive impressions. So cation, the T means a plus, could be positive. That's how you remind yourself that cations mean positive. Anions are negative. Okay, they have a negative charge, and how to remind ourselves is that. So anions are negative. So anion, negative. It's got the N in it for negative, or some people call it the onion ion. And if you bite into an onion, it's a pretty negative experience. So that's how we remember cations and anions, positives and negatives. So ion with a positive charge, so if it loses 1 or more electrons, it becomes a cation. That means its normal valence shell is almost empty. So these are things like the metals on the left hand side of the table. So for example, sodium, 11 protons, 11 electrons, it's going to lose 1. An anion, okay, if it gains 1 or more electrons and becomes an anion, so its valence shell is almost full. These are things towards the right hand side of the table. So for example, chlorine, 17 protons, 17 electrons. It's 1 away from having a full outside shell, so it's going to gain 1 and become a negative charge, because electrons are negative, of course, so extra means negative. And then we get things called a salt. Okay, a cation and an anion held together by what's called an ionic bond. We've got ions that are being formed, and they hold themselves together by what's called an ionic bond. So sodium has lost an electron, therefore it's got 1 extra proton, has a positive charge. Chlorine has gained an electron. I wonder if it came from the sodium, and therefore has a negative charge. Positives and negatives attract, of course, so we get an attraction between these two, and that is our ionic bond. So opposites attract. So ionic compounds have got a cation and anion together. Now the sum of the charges must equal 0. So if I've got a cation with 2 positives, I've got to have an anion that's got 2 negatives, or I might have 2 anions that are 1 negative charge each. They've got to balance it. So sodium chloride is reasonably easy, forms these lattices because the sodium was a positive and the chlorine was a single negative, and they join up, and therefore it's electrically neutral together. What about these ones? So aluminium oxide, calcium bromide, and sodium bicarbonate. What have we got? So the aluminium has a 3 positive charge. It's lost 3 electrons. The oxygen's only a 2 minus charge. Therefore we have to sort of combine them in this multiples. So we've got the little number 2 here and the little number 3 here replies to the element in front of it. So the 2 applies to that and the 3 applies to the oxygen. So I've got 2 aluminiums and 3 oxygens. So 2 times 3 positives make 6 positives. 3 times 2 negative charges make 6 negative charges. So that balances out 6 positives and 6 negatives. Look at the next one. That's a calcium's a 2 plus. Br's a single minus. That's why we've got 2 of them there. 1 of the 2 positives and 2 of the single negatives balance each other out. 2 positives, 2 negatives balance out. The next one, sodium is a single plus, and that whole thing there is the ion. Okay, that's the whole ion there, the carbonate ion, and it's a 2 minus. So we have 2 of the sodiums and 1 of the other one. It all goes together to balance each other out, make it a whole thing neutral. So reminder, an ion is an atom or a molecule with a positive or negative charge. And I hope that's been helpful.